We have the height in meters of a car on a Ferris wheel at time in t in seconds is given by this function here. h of t equals 18 times sine of pi over 10 times t minus 20. And all of this is in the sine function plus 18. And the first part of the question is, how long will it take for the Ferris wheel to turn 60 degrees? And we can do that by looking at what the period is. And the period, have an equation, period equals 2 pi over b, and b is this number in front. Just if we factor this out, so the pi over 10 is our b, so the period is 2 pi over pi divided by 10, and our pi's cancel out, that's nice. And we have as fraction inside a fraction, we'll multiply this fraction by 10 divided by 10, and if we do that, this 10 cancels out with this 10. This is like 10 over 1, and this is like 1 over 10, so that cancels, and we're left with 2 times 10. So the period is 20 seconds, and that 20 seconds is how long it takes to do one period, to go around one revolution. So it takes 20 seconds to go 360 degrees. And this ratio, because the wheel is spinning at the same rate, we can calculate the same ratio to go x. It takes x seconds to go around 60 degrees. This ratio has to be the same because it's moving at the same speed. So we'll isolate x, we'll multiply both sides by 60 degrees, and the 60 degrees cancels out on the right. So we're left with x equals 60 times 20 times 360. So x equals 60 times 20 divided by 360. 3 1/3. So x equals 3 1/3 seconds. 3.333 seconds. Okay, so the next part. If a writer starts at t equals 0 seconds, at what time is the height at 12 meters? And for this one, I think it's best if we graph the function. We can do that really quickly. If we have a graph here, and sine, remember sine normally goes like this, and this part right here is the origin, and we're shifted up 18 from the origin. So let's call this 18. That sounds fun. And this is a horizontal shift right by 20. So even though it's negative, it's shifting right. So this is 18 high, and we got to go 20 over. So this point is where this sine function is, like this. And it's going to go upwards. It's not going to go down because this is positive. It's not negative. So it's going to go kind of up like that. Anyways, we need to figure out the oscillations here. So this middle number, this is going to be this origin, which is like the middle part of the sine. So this is our middle part of the sine. And the amplitude is 18. So the highest it goes up is 18. Plus another 18, so that'd be 36. And then it goes down 18, so that'd be 0. So the maximum of this Ferris wheel is 36. The minimum is 0. And it oscillates up and down, but we need to know what the period is, which is 20 seconds. So here's 20. We'll do 40. I think that's pretty good. 20 and 40. So that's one period. So that means this is a half a period. This is a half a period. This is a full period. And it's going to go up. So it's got to be going up here, right? So it's going to go up to a maximum and then down. So it'll be a maximum right in between here. So each period you break up into quarters. See, this is a full period. Quarter, half, 3/4, full period. And it goes to the top, to the middle, to the bottom, to the middle, to the top, so to the middle. We're going to break this up into quarters. So this is one period here because it's 20. And we'll go to the bottom, to the middle, to the top, to the middle. Okay, and then we'll just connect the lines here best as we can. around and up, down. Okay, so this is our sine function. And at t equals 0, check this out. The rider is already at 18 meters. So we want to know when its height will be at 12 meters. Well, 12 meters is like right around here. 12 meters. So it'll be at this time and at this time here. So we need to plug in 12 for height here, which we will, into the equation. So 12 meters, I'll just leave the meters out. So 12 equals 18 sine pi over 10 t minus 20 plus 18. And you might be thinking, why didn't we just start off with the equation? There's a reason why we wanted to look at which way it goes. Okay, so we want to solve for this. So bed math, so 12 minus 18 is negative 6. 12 minus 18 equals negative 6, and then we'll divide by 18. Divide by 18. So, why is it 11? Shouldn't it be, oh, I need to put in brackets here. 12 minus 18, brackets, close brackets, divided by 18. There we go. That should work. Okay, negative a third. So negative a third equals sine of pi 10 t minus 20. And we will solve, this is some big ugly thing here. Let's call this theta. So, that's not theta. Let's call it big T. This stuff in here. This is big T. So negative 1 over 3 equals sine of big T. That means T equals the inverse sine of negative a third. And if you plug that into your calculator, I can't do that because this calculator doesn't do it, but I already did with another calculator. In degrees, if you're in degrees, you'll get 19.47 degrees. You could do this in radians as well. It works. So that means that this function, so this Ferris wheel is going to traverse negative 19 degrees. So it's going down. So it's negative because imagine you have this Ferris wheel. This is your Ferris wheel here. And the rider is starting here at 18 meters. See, the rider is going down after time 0. So we're going down. We're going in the negative direction. So that this point here, this is 12 meters in height. This is the bottom. This is 0 meters. This isn't really to scale, but 0 meters, 12. And then this angle here, this is our 19.47 degrees, and it's negative because we're moving in the negative clockwise direction here. So we want to know how long it takes to go 19.47 degrees. Well, we know the period way up here. The period is 20 seconds, and it takes 20 seconds to go 360 degrees. So we'll set up another ratio, 20 seconds to go 360 degrees. Is equal to how many seconds? X seconds to go 19.47 degrees. So we'll multiply, isolate X, of course, multiply both sides by, I'll just write it, DEG for degrees, by 19.47 degrees, and this side by 19.47 degrees, so that it cancels out, and we're left with X equals something. Wrong calculator. So 19.47 times 20 divided by 360. 1.08 seconds. So it takes 1.08 seconds. But what about if the rider keeps going? The rider will be at 12 meters a little bit later here too. So let's find out what time that is. So if this is 19.47 degrees, then this also has to be 19.47 degrees. You see that? So we need to know the time that it takes to go from here to here. So this would be half a revolution minus this little bit here. So whatever time it takes to go half a revolution, which is 10 seconds, because the period is 20 seconds. So it'd be 10 seconds minus the time it takes to go from here to here, which is 1.08 seconds. And this is 8.92, I believe. That's my mental math is good. 8.92 seconds to go. And now every revolution, the rider will be 12 meters off the ground. So really, if we want to know all the time up to infinity, so we'll say the rider will be 12 meters above the ground at, so we'll say 1.08 seconds plus n 20 seconds. And n is how many revolutions the rider has made. So when n is 0, they hasn't made any revolutions, so it'll just be 1.0 seconds. If the rider's gone around once, it'll be 20 seconds to go around, plus another 1.08 seconds. And then we can do the same thing, 8.92 seconds plus n times 20 seconds to capture every revolution right here. All right, everyone. Hope you enjoyed it. See you in the next one. Cheers.